So this question will not be included in your assessment, right? This is related to the space theory, right? All right, so we are taking a start from question number 2. And this question paper is from November 2025. Right? A car travels at a constant speed of 14 meters per second along the road. Calculate the distance traveled by the car in a time of 30 seconds. Use the formula distance traveled equals to average speed equals to time taken. So we know the speed, we know the time. We can easily multiply these two things. The driver of the car sees an obstacle in the road ahead and applies the brakes. Which of these is a description of the thinking distance of the car? The distance traveled between applying the brakes and the car coming to a stop. Applying the brakes, okay. And the car coming to a stop. Distance traveled between seeing the obstacle, yes. Thinking distance always includes when the driver sees the object and applying the brakes. Okay. So B should be the answer. Distance traveled between seeing the obstacle and the car coming to a stop. Coming to a stop does not depend on thinking distance. Okay. Uh, Again, this also does not uh, include the thinking distance. Distance traveled as the car slows down. Distance traveled as the car slows down. So this is completely a weak statement. So the answer is B, right? Distance traveled between, when the driver is seeing the object and applying the brakes. Which of these factors would increase the braking distance of the car? Car traveling at a lower initial speed. Okay, would increase the braking distance. Would increase the braking distance. Yes, would increase the braking distance. Yeah. Because why A is incorrect? Because remember, A is talking about a lower initial speed, right? So lower initial speed actually, it is the, this is the braking distance, right? Sorry,
Yeah.
it would decrease the braking distance, right? It would decrease the braking distance. And what about the B1?
This increases the thinking distance.
Yeah, it increases the thinking distance. and worn tires on the car, yes, it would increase the braking distance, the worn tires on the car, right? So C is the answer. And dry road instead of wet road, it decreases the braking distance, okay?
Okay.
It comes to stop quickly on the dry road. State the only factor that affects both the thinking distance and the braking distance of the car. State the only factor that affects both thinking and braking distance. Yes, thinking and
Speed of
braking.
the car.
Yeah, speed or velocity. Okay, speed of the car or object. Now here's question number three. This is a simplified diagram of electrical wiring in a house, and it says that a current larger than 32 ampere flows in the sockets. All right. Since you can observe that the AC circuit, right, and a parallel circuit as well, right? Circuit breakers are installed independently in each branch. One circuit breaker is 6 ampere and one circuit breaker is 32 ampere. Describe how having the circuit breaker in series, sorry, describe how having the circuit breaker in series with the sockets protects the house. Basically, they are asking how the circuit breaker, protects the house. Okay, how the circuit breaker helps in protecting the house. See, there's a ratage of the circuit breaker, right? So if that amount of current or high amount of current comes, so what will happen? What will happen? The circuit will, the current will stop and the circuit breaker will break. Okay. Okay. So if the large amount of current flows, the circuit breaker open and disconnect, right? Okay, stops the current to flow, stops the current to flow, right? This is clear.
Yeah.
And uh, we can also write with respect to the overheating, okay? So that no overheating will be caused, okay? Our student suggests that fuses could be used instead of the circuit breakers, right? So fuses could be used. Uh, Give two disadvantages of using fuses instead of circuit breaker. Yes, the fuse is also a thin wire, right? Yeah, fuse
Yeah.
is also a thin wire. But what happens when the large amount of current enters the fuse itself? What happens? It it breaks, right? Okay,
Yeah.
and it cannot be reset, right?
Yeah.
So fuse is a thin wire, large amount of current flows. The wire breaks. Okay, uh, the fuse wire. We can also write flows. The fuse wire breaks. Okay, and mm, cannot be reset. Okay, it has to be replaced. Yeah, it cannot be reset. It has to be replaced. And fuse uh, does not does not cut off the current instantly. Okay, it stops current slowly, right? Right, yeah.
Yeah.
Explain why the wiring in the house includes an earth wire. Why this wiring in the house includes the earth wire.
To direct the current to the ground if there's a surge.
Right. So if because since earth wire is there, so if someone touches the live wire, right, live wire or metal case, right, so what will happen? The current will flow and then it will connect to the earth. Okay, and current flows through the earth wire as well. Okay, current flows and ends to the earth wire, right? And it also, it also uh, earth wire also prevents the electric shock, right? Yeah, and ends to the earth wire. Uh, it it helps it helps in uh, it helps in tripping the circuit breaker. Okay, by providing low resistance, right? Any confusion there?
Oh, what do you mean by the last point?
It helps in tripping the circuit breaker. It helps in tripping the circuit breaker because earth wire has a low resistance. So if any current enters, excessive amount of current enters the circuit, so it can be, it can easily be grounded. Okay,
Oh, okay. Yeah.
it can easily be grounded. Now let's come to question number 4. The diagram shows a force pulling a block up a ramp. Okay. Uh, 120 Newton force is acting. Uh, and height is about 0.82 meters, right? Show that the work done by the force is work done by the force. Okay, by the force, this force, right? By this force is about 440 joule, right? So uh, since we know that this force is acted from this distance to that distance, right? Okay, this force is acted with this path. So therefore, we have to take this one, right? So the distance moved by the block is 3.7 meter and the force is 120 Newton, right? So what should be the answer?
Four.
Yeah, it's going to be triple four and it's going to be about 440 times, right? So if you can see that all values are into significance, right? So they also want the answer into significant. Therefore, they are just writing, they are just asking us to show the answer about 440 joules. Okay. Now the block gains 12 joule of energy in its gravitational store when it is lifted through a height of 0.82 meter. So block gains 12 joule of energy in its gravitational store when it is lifted through height of this. Calculate the mass. Okay. So uh, the gain of energy from the ground to this height, okay, is 12 joule, right? So when the object is placed and is lifted, sorry, when the object is lifted, so it gains gravitational potential energy, right? So gravitational potential energy, we know that it is equal to mgh, right? So we know that this energy is going to be gravitational potential energy, and we do not know the mass. We can take a 10 Newton per kilogram, okay, and height is going to be 0.82 meter, right? So 12 m times 8.2, and then 12 divided by 8.2. Okay. Yeah. So now this time 12 divided by 8.2 would be 1.46, right? 1.46 kg. Is this clear?
Yeah.
So this number and this number, they both aren't too significant. So you can also write 1.5. Okay, clear?
Okay. Yeah.
A student states that most of the input energy is destroyed when the block is pulled up the ramp. Okay, the student states that most of the input energy is destroyed when the block is pulled up the ramp. Comment on this children's statement. Okay, how can we say that the most of the input energy is destroyed? You need to compare this one and this one. Oh, sorry, this one, this energy, 12 joules, and this one, right? This is the input energy, right? Because you are applying a force and you are doing a work, and work done on the object is equals to energy transfer, right? Yeah, work done uh equals to energy transfer, right?
But, energy cannot be destroyed. So how can like you say it's destroyed?
Oh, okay, okay. Uh, our student states that most of the input energy is destroyed. Destroyed. Okay, okay, yeah, yeah. When the block is pulled up the ramp. It should not be used as destroyed. We can say that it is dissipated. Okay. Most of the energy is dissipated because the energy that is, that is in spent on this block from this point, let's say point A to B, this energy is going to be 440, right? Is about 440. Okay. And the energy that the body has stored when it is lifted, so through this way, it is going to be around 12 joule. So most of the energy is, wasted or dissipated in the environment, maybe in the form of the heat. Okay. Right. But
Mm.
over here, they are talking about input energy is destroyed. So yes, you are right. We can't say that energy cannot be destroyed, right? Yeah, but we can say that energy is lost or dissipated in the form of heat. Okay, so uh, energy energy cannot be destroyed. Okay, energy is wasted or lost in the form of heat when the work done when the work is done. Sorry, when the work is done by 120 Newton. Okay, so uh, energy energy transfers to gravity, right? No, no. Is there any confusion?
No.
All right. So this question is not included. This topic is radioactivity. Magnetism is not coming. Okay, so this question is related to the uh, brightness of the light in a room. That is electricity. Okay. So the diagram shows an electric circuit used to determine the brightness of the light in a room. So it will take. Oh, okay. Type, should I restart the meeting so that other
Oh,
students can join?
okay, yeah. I'll have to pray first then.
Okay, right. You
'Cause
can
my
join.
prayer is soon.
Right, right. So you'll be joining in 10 minutes or 5 minutes.
My prayer is at in 30 minutes, I think.
Okay, okay. All right. So I'm ending and then you can join whenever you are.
Okay.
All right. Thank you.